What up YouTube, TK here, and today we are back with everyone's favourite mess of wires, TKIRV. Let's go. Now in the last episode, we finally got TKIRV running on the 4G wireless network. We could drive this thing around with the webcam and see what was going on, and it was awesome. However, one of the big things that was really holding us back was the motor control. You see, it's basically on or off at this stage, full power or none, which makes it very, very hard to drive the robot accurately when we've got a laggy connection, which we probably always have when we're running on the mobile network. So to deal with that, what we're going to do is we're going to replace the standard motor controller that came with the remote control car with a variable unit. Now, what is great about that is it will actually allow us to throttle the motor, so we can set it to 10%, have it crawl while we're watching the webcam feed and, you know, just steer and drive a little bit more delicately rather than smashing the throttle and then hitting a wall and then reversing and then hitting something else while we wait for the camera to update. We just won't have that problem anymore. We'll be able to crawl around slowly. I have a feeling that's probably how NASA does it on Mars, and that's how we're going to do it here. So let's get into it. Now this here is the speed controller we will be using. It's a brush speed controller from Hobby King, 45 amps. It has forward and reverse. Also has brake, which we're not too worried about. Has a little programming button here, battery in, motor out, a switch, and also the servo lead. We're just going to use the servo control signal from the Raspberry Pi coming into this to tell it what to do. Shouldn't be too hard to get wired in. In fact, should be remarkably easy. So let's do it. We'll start by cutting out the old board. As they say, out with the old, in with the nucleus. So yes, those can go. And that can go. We have our two wires with battery voltage there. And we have our motor wires, blue and yellow, there. Those are going to attach to our speed controller. What I love the most is how much space this actually frees up. This thing is positively tiny, and we can probably just mount it there, especially in the short term. So first thing, obviously, strip the wires. These will provide full battery voltage to our delicious, friendly speed controller. Now we're just going to splice these in because it gives us plenty of length. We can always do a neater job later. And if Alex was still here, he would be chastising me greatly for not doing this properly the first time, as he should. Doing a typical lineman style splice, or something approximating it, which is a nice, strong solder joint. Very different from how I used to do it, which was bad. If you're a newbie, please notice that we're doing all this soldering with the battery disconnected. Generally, I find it's good to wait a couple seconds after soldering before moving the heat shrink into place, because otherwise the joint is still so hot that the heat shrink starts shrinking as you're sliding it over the joint, and it makes a big mess. So we've just waited a little bit before that. Also be careful of any pointy bits of wire that end up sticking out through your heat shrink, because those could just as easily cause a short circuit as anything else. The next step is to attach the motor leads. Now we should think about polarity, i.e. we want forward to be forward, reverse to be reverse. However, because we're doing all this in code, we can just flip things, so it doesn't actually really matter that much which way around we arrange these. So I'm going to go ahead and pretend this is going to sit here, and we'll just go ahead and wire them up the simplest way possible. Besides, blue is occasionally used as negative, so that's good enough justification for me. And now we're just going to solder in a jumper to GPIO pin 17, which we'll be using for another servo blaster output, which will allow us the finer control over the motor speed, which we so desperately desire. We'll grab this white lead here, and this is the signal input to the speed controller, and we'll go ahead and wire that up to GPIO pin number 17, just like God intended. So we're changing to a speed controller from a formerly on-off throttle control system. We have to make some changes to the code. First things first, we must change the initialization for Servo Blaster, because the speed controller uses the same signals that a servo does. So we'll tell it we have another servo connected to pin 11, which is actually GPIO pin 17, but you know, try to keep up here. We will then have to change the code. Now, the next thing we have to do is change the way this program actually responds to throttle events. Now, we're not going to go with full variable control right away. All we're going to do at this stage is have it so that when TKIRV receives a throttle signal, it drives at, say, 15% forward or 15% reverse speed, not full speed right away. And that, you know, should make it a lot more controllable. The way we do that is by first getting rid of these GPIO signals and replacing them with calls to Servo Blaster. Easy enough. Where we used to send signals to the transistors that interface with the original control board, we've replaced that with calls to Servo Blaster, which sends signals to our new speed controller. 50% is neutral. When the controller receives a 50% signal, it wants to go neither forward or backward, it just stops. That's good. So whenever we want to stop, when we're receiving no forward or no backward signal, we send this 50% duty cycle through Servo Blaster on channel 1, which tells the speed controller we don't want to go anywhere, just switch the motor off. Now, when we want to go forward, we send this 35% duty cycle signal. Now, remembering the lowest we can send is 0, the highest we can send is 100. So if we send 35%, that's roughly saying to go forward at roughly 30% speed. Does that make sense? I'm not sure. When we want to go reverse, we send this 65% duty cycle, which again, roughly turns into going in reverse at about 30%. Now, it would be cool if we go 51, 52, 53%, you know, really dial it slowly. But the thing is, there's all this friction in the gear train and this inertia to overcome to actually get the car moving. So you generally can't actually go there. For now, this should be a nice, good starting point for us to work with. Now, because we've actually made the changes entirely on the TKIRV side, we actually don't need to make any changes to our control program because it's still just going to send a signal for forward and reverse. So we'll go ahead and fire this up on both ends. We'll go ahead and fire things up on TKIRV. Excellent. And then we will fire things up on the computer if we can remember how, because it has been many, many months. Looks good. Let's go ahead and point this camera at TKIRV and see if it works. We will put these flags on so you can more easily see which way the motors are turning, and hopefully it will be working properly in forward and reverse as well. We'll now try going in forward and reverse and see if that works. So left, right. Okay, so that is me pressing forward and yet the motors are turning backwards. And yet if I press reverse, the same thing happens. So I will have to go and take another look at the code. So the reason that isn't working is actually quite simple. It's to do with my signaling setup and the original hardware of TKIRV. The original hardware of TKIRV had one point which fired the motor in a single direction, and then another point on the circuit board which, when fired, would click a relay which reversed the motor wires, reversing the direction. So when we sent these signals from the control program, we sent a signal to fire the motor when we wanted to go forward, and then when we wanted to go reverse, we sent a signal which meant fire the relay and fire the motor. We don't want to do that anymore. We just want to send a signal for forward and a signal for reverse, and we'll interpret it on the other end onboard TKIRV. So we're going to fix that now, and hopefully things should work better. We've refactored the code on two fronts. First, on our control program, we've changed things so that when we want to go forward, we send this first bit. When we want to go reverse, we send the second. It no longer sends both bits when we're trying to go reverse. That simplified things greatly. Then we come over to our code here on TKIRV. Now, what we do is we combine the if statements for both forward and reverse so that they're exclusive, because that will reduce confusion for the speed controller. Now, if we see the highest bit set, we send a signal for forward. Else, if we see the second highest bit set, we send a signal for reverse. And if neither is set, then we send a signal to the speed controller to turn the motor off. Simple, hopefully. Let's try it again. All right, here we once again have TKIRV, and we've changed our code and also corrected a very embarrassing spelling error, which was probably causing us no end of trouble. We will now fire up the drive program and fire up the control program, and we will go reverse and we will go forward. That is awesome. We will now bolt the wheels back on and try and drive this thing around. I cannot wait. All right, she's ready. Moment of truth, really. Can't wait to see if this actually works. Give it a go. More controllable because it's slower. No, it's still really fast. We might have to dial that down more. We might have to dial that down more. Let's try changing the numbers a bit. Still way too fast, but that's okay. What we will instead do is dial it down a bit. Now, eventually we will probably put in control of these numbers into the computer side program, so we don't always have to edit the Python. We can just have a throttle slider in our control program instead. But for now, we're going to do it here because it's quicker and easier. So instead of 35%, we'll change that to 40. Instead of 65%, we'll change that to 60. Maybe we go even more than that. Let's go 43, which is closer to our central point. And we'll go 57, which again, closer to our central point. Only 7% difference instead of 15. Hopefully that's still enough to overcome the resistance in the drivetrain, because if it's not, I don't know what we're going to do. Now we're crawling. That is much better. Obviously, this is excellent for crawling around without hitting things, especially when you have lag on your video link. So with its new speed controller installed at the back here, the thing's looking really rather cool. And in addition, it's a hell of a lot more drivable. And to show you just how much it's improved, we're going to take on a little drive through the house, which is quite a tight little course. Let's go. So with our fresh modifications, we want to actually test TKIRV, and we want to see if it is actually more controllable, and for that purpose I have devised a test course. Now, it's nothing interesting or fantastic. I'm simply going to try and drive through my tiny little house from my office to the back garden. Now, that may not sound like much, but it is in fact the perfect test, because it is through quite a cramped little hallway with some obstacles, which is really perfect. When we tested TKIRV in the past, we couldn't keep it on the footpath. I feel like if we can do this, we can do anything out there. So I'll now show you the process of getting TKIRV booted up and under control from scratch. Alex would be disappointed that I haven't improved this after all these months, but them's the breaks. So we're already online, we're on OpenVPN, TKIRV has automatically connected. I'll open up command prompt and I'll fire up GStreamer on the laptop. So sometimes we have to make some changes depending on whether we're using the Intel or the Nvidia card on the laptop. So this is the GStreamer launcher for the Intel card. Launch that, switch over to a PuTTY window connected to the Raspberry Pi, launch the 320 stream, and we have video. With the video working, we then open up another PuTTY window and we start up our drive program on TKIRV. That's now listening for connection. We then open Notepad++, which has our control program, and we fire that up and hope it works, and it looks like it is. And then now we can finally drive. So we'll hit left and we'll just start to walk her outside. And because we've got this slower speed controller, we can actually do this really, really well, especially when you take into account the lag inherent in, doing this over 4G. So we're gonna drive, and it's so tempting to look over my shoulder at the car itself, but I'm now driving this entirely on video, and you can see a bottle of bleach there in the distance. Okay, through the laundry. Come on, this is an adventure. This is great. Looks like a pair of shoes. Oh my god, this is excellent. What I would love now is a gimbal on the camera so I could see if I'm actually going to hit that laundry air dryer. I have a feeling we're stuck on it, but we'll see how we go. Yep, we are stuck on it. Now let's reverse, let's go again. Yeah, we are getting stuck on the leg of the closed error. So that is a problem. But I think we've done a better job this time. It's very tight through here. Oh my god, we're actually getting through. This is fantastic. We're gonna go outside. Holy crap. There's the bleach. And now we're outside where it is incredibly dark. There's my chairs.
The camera does not like the darkness at all. Let's see how far we can get. Probably not very far. Okay, and now we're just driving into the blackness. Holy crap, we actually made it outside. So obviously now, you know, we can't see anything because it's just too dark outside. TKIRV really needs some headlights, and we're going to do that, I absolutely promise you. But the simple fact is we managed to drive into the back garden using nothing but video. We didn't hit anything too badly. There's my couch out the back. And we can now drive back in. Holy crap, this is actually just... It's hard to describe how much more drivable this is than before, because we can just cruise around at part throttle. Now obviously, I have hard-coded this. The throttle is set at 20% and that's it. If I want to change the throttle position to get over an obstacle at this point, I have to go back, change the code and fire back up. And that's frustrating. Eventually I probably will put in throttle management into the drive program, but for now, just being able to cruise around without, you know, smashing into everything every 2 seconds is awesome. This is so cool. Just don't quite have the power to get up that hump. Or do we? No, with a bit of creative driving, we are almost in. This is fantastic. You're getting a great tour of my house, by the way. A gimbal would really be great, or a different camera position so you can better see. I just hit a bucket. So you can better see what you're doing. It might not be that funny to you, YouTubers, but for me, I can actually hear the remote control car smashing into stuff in the laundry 10 meters away, and it is most amusing. Yeah, fuck off, bucket. Alright, we'll just ram this bucket along in front of us then. If that's the way it's gotta be, that's the way it's gotta be. I'm getting out of here, bucket or no. This is fantastic. I've built a robot that can shove buckets around. I'm having the time of my life. Let's see if we can get back. Oh my god, we're doing it, people. That heater is broken, by the way. There's a Coke bottle. I do drink too much soft drink. There's the plates. Oh my god. You're gonna see a bit of a twat in a minute. Alright, let's see if we can get this guy in picture. There he is, ish. So fundamentally, this has been really cool. With the new speed controller, the robot is just so much more drivable. I got it through my house, even through the laundry, which is full of crap. No problem, made it outside, made it back in. It's just so much more drivable. Future work will require me to do a bunch of network code so I can change the throttle setting on the fly, but that's very doable. Other things that are going to happen next, obviously the solar panel, which we've been talking about for so long, and then it'll just be a matter of taking TKIRV out into the wilderness, given 4G coverage, and we'll see what this thing can do completely untethered. But yeah, I'm excited. This is just so much fun to play with now. Till next time, TK out.